In this video, I'm planning to explain limits involving infinity. And actually, we cannot understand the infinity, but we can guess how it can be. And the important part here, when the function x tends to 0, when x gets closer to 0 from the positive side and negative side, as you see that this is the graph of the function, and graph is getting closer to up. This arrow shows us also to us this value is going to infinity. To understand this one, I can give these examples like 1 over, if I say 0.1, which is 0.1 is a number that is closer to 0, and 1 over 0.1 it's going to be equal to 10. Or when you divide by 1 over 0.01 is going to be equal to 100, and 1 over 0.001, as you understand from the logic now, 0.1 if it is 10, 0.01 if it is 100, 0.001 is going to be equal to 1000. And as you see, 1 over the number is decreasing. This is 0.01 is very small number, and this is 0.001, and that's smaller than 0.01. And as you see, when you decrease the number here at the denominator, you are increasing the value of the number for the rational number. So here, if you use infinitely many numbers like 0.000, and this number, huge number, it's going to be 1.000, it's going to be, and how many zeros here? 5, and here 1 more I'm going to add. So okay, now as you understand, when you make this number smaller, it means that this is going to be the number value of the 1 over x, it's going to be bigger. Okay, then when you get closer to 0 from the negative side, it means that that number is getting closer to infinity. Here also we should explain this one. Minus 0.1, it's going to be equal to minus 10, and 1 over minus 0.001 is going to be equal to minus 100. So 1 over 0 from the negative, it's going to be minus infinity, and 1 over from the 0 positive, it's going to be positive infinity is going to be. We are going to try to understand like this. Okay, now here this line is called the line is called asymptote. This line is called asymptote, and it's a boundary for the function. When the function tends to infinity, that number get closer to c, and I'm going to explain how it can be like that. Okay, now let's try to understand 0 plus, and for the 1 over x function, what is going to be the 0 plus and what is going to be the 0 minus. Okay, here limit x tends to 0 from the positive side, 1 over x is equal to 1 over 0 plus it's going to be, which means infinity. I try to explain that one. 0.01, 0.001, I try to explain that case. And limit x tends to 0 from the negative side, 1 over x is going to be equal to 1 over 0 minus it's going to be, and that's equal to minus infinity. So for the 0, limit doesn't exist. First we should understand that one. Second part, C, this is A, this is B, and the C1, limit x tends to infinity. This time the case is 1 over infinity. 1 over infinity, to understand the 1 over infinity here, sorry for the 1 over x, 1 over infinity I'm looking for, and 1 over infinity, it must be equal to 0. Why it's 0? Because 1 over 10, when you say this is 0.1, it's going to be 1 over 100. When you say it's going to be equal to 0.01, this number is more closer than this one to 0. This number is more closer than this one, and as you see, when you increase the denominator, 1 over 1000 is going to be equal to 0.001, which is very close number to 0. So approximately 1 over infinity, we are going to write like that, is going to be equal to 0, or 1 over minus infinity, positiveness or negativeness, there is no for the 0, that's why it's going to be equal to 0 again. So the D1 also already solved. Limit x tends to minus infinity 1 over x, it's going to be 1 over minus infinity, that's equal to 0. Here the important part, the reason for the limit in the functions topic, you cannot apply these numbers directly. What I mean, you cannot give the numbers here 1 over x 0 plus to 1 over x function. You cannot replace the 0 by x here. So limit allows to do this operation, That's why we are solving the question by using limit. And do not forget that these are all y values. This is y value, y value, y value, and y value of the graph is going to be. Here there is a graph of the function, and when x gets closer to 0 from the positive side, as you see, it goes to infinity, and when it gets closer to 0 from the negative side, it goes to negative infinity. When function goes to infinity this side, when it goes to this side, as you see, the function is getting closer to this number, the x value is here 0, or when it goes to, function goes to minus infinity, function is getting closer again to 0 value. Function value means, if you remember, function, when I say function means y value, so the function value is y value. If we find the limit of this function, here it says find the limit of the function, limit x tends to 1 from the positive side, and limit x tends to 1 from the negative side we have to find, and the function fx is equal to 1 over x minus 1 is going to be 1 over x minus 1. For this kind of questions also we can use the 1 plus h method also. Here to understand easily, if I replace 1 plus by 1 plus h, it's going to be equal to 1 over 1 plus h minus 1, and the result is going to be 1 over h, and 1 over h is equal to 1 over like 0 plus 1 over 0 plus, and which is equal to infinity. And here it's going to be equal to 1 over 1 minus h, because 1 minus h minus 1 is going to be, then it's going to be equal to here 1 over minus h, which is equal to 1 over 0 negative, which is equal to minus infinity. It's going to be okay. So when x get closer to 1 from the positive side, the function goes up to positive infinity. Here it's going to be like this, and when x get closer to, here it's going to be, I think, here it's going to be like this, and when the function get closer to 0 from the, 1 from the negative side, from this side, when you get closer to 1, the function is going to minus infinity, so the function, something like this it should be here. Okay, when you get closer to, so we found the limit, limit doesn't exist. limit doesn't exist because left-sided limit is not equal to right-sided limit is going to be. Okay, find the limit of this function when x approaches to plus infinity. Here we have one special method for this kind of solutions. I want to show that one only. Limit x tends to 0 plus, it's going to be equal to 2x squared minus x over x squared plus 4. Later we are going to solve this kind of questions by using the derivative rules. Also applications limits involving infinity, the second part of the limits involving infinity, also it gives the answer of this type of questions. But here I'm going to use this method. Now limit x tends to infinity plus infinity. I'm going to get x squared parentheses, and you can do this one if you are using limit sign. That's why it's going to be equal to 2 minus, when you get x squared from the x, it's going to be x over x squared. Then this is going to be equal to x squared down, it's going to be 1 plus 4 over x squared is going to be. Okay, then this x squared and this x squared you may simplify. Limit x tends to, the equation becomes, limit equation becomes 2 minus 1 over x over 1 plus 4 over x squared is going to be. Okay, then 1 over x, 4 over x squared I have here. What is the 1 over infinity? 2 minus, as I said, you cannot replace by infinity, but we can approximately understand what is 1 over infinity. 1 plus 4 over infinity squared it's going to be. And we know that this is going to be 0. Infinity squared is going to be equal to infinity. That's why this is again 0. So the answer is 2 over 1, which is equal to 2. It must be.